Today we're going to focus on dilations on a coordinate plane, and we will be dilating around the origin. When we dilate around the origin, we use the rule xy forms x times the scale factor, y times the scale factor. And so we'll look at our first example. We see that we have a scale factor of 1/2, so the first thing I'm going to do is write my rule. X comma y forms 1/2 x comma 1/2 y. Now that I've written my rule, I want to identify each of my ordered pairs. So G is found at 0, comma, -2. Y is found at -3, 0. M is found at -3, -4. Now that I've found all of my ordered pairs, I plug them into my rule. So my first ordered pair, G, has a x value of 0, so I multiply 0 times 1/2, and I end up with 0. My y for my ordered pair G has a value of -2, so I multiply -2 times 1/2, and we'll see that the 2's can simplify out. That leaves me with -1. So my new ordered pair for G should be found at 0, comma, -1. Now let's find my new ordered pair for Y. So again, we'll multiply the x value, -3 times 1/2, and we end up with -3/2. And we'll multiply our y value, 0 times 1/2, and we end up with 0. And so we should end up with a y value at -3/2, or as a mixed number, that would be -1.5, 0. Then we can dilate our last value. -3 times 1/2, again, that's going to be -3/2. -4 times 1/2 will be -2. And so we should find an ordered pair at -3/2, -2. Now, in order to finish the problem up, I would want to connect the vertices and appropriately label. If you guys continue to leave off labels, I will continue to mark off points. Next, we want to dilate the image by a scale factor of 2. And I can already look at this image and realize that if I dilate by a scale factor of 2, I'm going to end up with a lot of ordered pairs that don't even fit on this graph. So for the purposes of this problem, we're going to assume that the image was given just as a reference, and we need to be able to show our work to validate our solution. So the first thing I will need to do is provide my scale factor, my rule. X comma y forms a scale factor of 2, so my new ordered pair will be at 2x, 2y. Again, I want to label my coordinates, so we'll have J, M, E, X. J is found at -2, -3. M is found at 1, -2. X is found at 3, negative 3. E is found at negative 2, negative 4. So now that I've found my ordered pairs, I can simply apply my scale factor rule. So for J, I plug in the X value of negative 2. So negative 2 times 2 gives me negative 4. I'll plug in my Y. Negative 3 times 2 is negative 6. And my new ordered pair for J prime would be negative 4, negative 6. Now, as I mentioned, negative 4 is on the graph, but negative 6 falls beyond the graph. And that was one of my ordered pairs that had a smaller xy. So most of the rest of the coordinates are not going to land on the graph either. That's okay, we can still show plenty of work to demonstrate that we know how to dilate the figure. M prime, we plug in the x value. 1 times 2 is 2. Negative 2 times 2 is negative 4. So we end up with an ordered pair of 2, negative 4. E, 3 times 2 is 6. Negative 3 times 2 is negative 6. And finally, X prime. Negative 2 times 2 is negative 4. Negative 4 times 2 is negative 8. And again, since these points are not going to fit on the graph, it's sufficient to show my work with the ordered pairs to validate my solution. Next, we're going to dilate by a scale factor of 3. Again, we'll notice that it's not going to fit on the graph. And to be honest, unless we start with really small images, anytime you're dealing with a scale factor greater than 1, which is going to cause your image to get bigger, it's probably not going to fit on your graph if you have a small image like this, or a small graph like this. So we want to show using our rule. First, the rule is x comma y forms 3x comma 3y. And so we'll identify our ordered pairs. J has a value of negative 5, comma, negative 2. L has a value of 0, negative 3. Z has a value of negative 4, 0. And so now we can dilate. Negative 5 times 3 is going to be negative 15. Negative 2 times 3, negative 6. L prime, 0 times 3 is still going to be 0. Negative 3 times 3, negative 9. Z prime, negative 4 times 3 is negative 12. 0 times 3 is 0. And so we have sufficient work to justify our solution to the problem. Now, in addition to being able to dilate figures by a scale factor that's consistent with both the x and y, we can also dilate by inconsistent scale factors, and those will create stretches or shrinks. And I want to talk a little bit more about those for just a moment here before we look at examples. A scale factor that dilates both the x and the y by the same value is going to create two similar figures. We're going to talk about similar figures and congruent figures over the course of the next 2 days as we approach next week. A scale factor that dilates a figure only by either the x or the y will not create similar figures. So if only the x or the y is multiplied, then you are working with a stretch or a shrink. If x is affected, it will be a horizontal stretch or a horizontal shrink. Again, stretch means it's getting larger. Shrink means it's getting smaller. If y is affected, it will be a vertical stretch or a vertical shrink, which makes sense because our x values affect everything left to right on our graph. That's horizontal. Our y values affect everything up and down. That's vertical. If the scale factor is between 0 and 1, as I said, it will be a shrink. If the scale factor is greater than 1, it will be a stretch. And while we're talking about it, let's also remember that a scale factor of 1 will create a replica image. So let's look at some examples. XY forms 4x, y. Now we should realize that only x is being impacted. So this is not going to create a similar figure, but rather it's going to create a dilation with a horizontal stretch. By multiplying the x values times 4, we're increasing the distance of any line connecting those x values. Number 2, xy forms x, 5y. Well, here we're noticing that we're going to end up with a vertical stretch. 5 is greater than 1, and so it's going to cause my vertical values or my y values to increase by a factor of 5. Number 3, xy forms x, 0.4y. Well, since 0.4y or 0.4 is a value less than 1, it's going to cause my y values to shrink. And so we would describe this as a vertical shrink. Let's look at some examples. Our description tells us to perform a horizontal shrink by a scale factor of 0.5. First, we want to start with writing the rule. So xy will form horizontal, we remember impacts the x value only. So 0.5 x, y. So we can see from our ordered pair that 0.5x is going to cause my x values to get smaller. And there's no number in front of y or the understood 1 in front of y, so my y value will stay the same. Now, just like our previous problems, it's helpful to identify the ordered pairs. So we'll have a j at -5, -2. We'll have an L at 0, -3. And we'll have a Z at -4, 0. And just like we did with the previous dilations, we're going to plug our values in. So we have an x value of -5 times 0.5. 0.5 we know is the same as 1/2, so half of 5 will leave me with -2.5. There was no factor or value in front of the y, so I simply plug in my y. My y value for my j-ordered pair was -2. It will remain -2. So we have an ordered pair at -2.5, -2. Next, L. We plug in our x value. 0 times 0.5 gives me 0. -3 gets plugged in for y, -3. And so we see no change in L. Z. We plug in our -4. -4 times 0.5 gives me -2. Plug in our y of 0. So we should have an ordered pair at -2, 0. Now we can connect our dots, label our primes, and have a concluded problem. Next example. We want to perform a vertical stretch by a scale factor of 1.5. So I'm going to start with the rule. X, y forms a vertical stretch, has no impact on the x value. So x, 1.5 y. Ignore the stray mark on the y. And so again, we need to start with identifying our ordered pairs. We have G at the value 0, -2. We have Y at the value -3, 0. We have M at the value -3, -4. And now we can dilate using our rule. And so we'll start with plugging our x value in. 0 plugs in for x, so that gives us 0. -2 times 1.5 gives us -3. We end up with an ordered pair at 0, -3. Our next ordered pair, y, we plug in the -3 for x. We multiply 0 times 1.5, which gives us 0. And our y value should be at the ordered pair -3, 0. Our next ordered pair is m. So m prime, we plug our -3 in for x. We plug a -4 in for y. -4 times 1.5 gives us -6. And our new ordered pair for m prime, it will be -3, -6. Now, as you notice, I had my dots come in backwards, but that's okay. This one did not necessarily need to be graphed because we would have noticed that one of our ordered pairs would not have appeared on the graph. If it doesn't appear on the graph, then I will accept you either giving it as you see on the screen, where it's slightly off the graph but in an appropriate spot, or simply giving me all of the ordered pairs and their appropriate primes.